Okay, Assalamualaikum warahmatullahi wabarakatuh. Let's continue on the next subtopic of hydrostatic fluid pressure, which is pressure variations. Okay, this is the cylindrical fluid elements of constant cross-section area, means the size of pipe is same from the vertical plane. Okay, the shear stress is zero because the fluid is at rest. And then if it is from vertical plane, we can see the elevations that represent by Z. At N, there is change of elevation, dz. Okay, when the elevation is changed, the pressure also change. So from M to N, at N, there is a change of pressure here. And then here is the datum. What is datum? Datum is the lowest and highest point of fluid pressure. Okay, then we need to summing up all forces along the axis to determine the change of pressure. So the first point is a pressure force in the directions of the flow. So the force is pressure times area. So we have PA. And then at N there is opposite directions. So we use negative here, and then pressure times area. The pressure plus the change of pressure times the area at N. This is N, this is... Okay, then we minus the weight. Weight is density times gravity times V. So this is the rho G and V. Okay, so we are using cos theta because it is inclined plane. And then after we calculated using standard mathematicals, you get change of P, change of pressure is equals to negative density times gravity times change of length times cos theta. Okay, then we have two elements, which is horizontal and verticals. Okay, what's mean by horizontal means the view is from above, and verticals is the view is from side. Okay, then for horizontals, the angles is 90 degree because the view is from above, so you have 90 degree angle. And then substitute the angle in the formula of change of pressure. We get the change of pressure is zero. Means that at view from horizontal, there is no elevations because from above view, there is no elevations. Means that at anywhere in a static fluid, the pressure is constant. Okay, the pressure is constant. Even the picture shows that there is incline. If in the question state it is horizontals, mean there is no elevations. Okay, for verticals, the angles is given by 0 degree, and the cos dz over ds, and then we substitute the cos inside the formula. So we substitute the ds. So ds is dz over cos theta, cos 0. And then we get the change of pressure is negative density times gravity times change of z. Okay, what is the meaning of this? There is pressure varies with respect to elevation. When there is elevations in the pipeline, means the pressure also different. So the same pipe, when we see from the vertical, daripada sisi, kita nampak daripada sisi, kita akan nampak elevation. Bila pandangan daripada atas, horizontal, we cannot see the elevations. That's why the change of pressure is 0. For vertical, it's not 0. And then next. Okay, the pressure is the same at all points on her horizontal plane. So Point A and point B is the same horizontals, means same pressure. Point C also same horizontal plane, means point C is the same pressure. Even the different shapes is happen. Okay, different geometry. Okay, however, there is also different at pressure H and pressure I. This is because of the difference of density, mercury and water. And then let's recall your knowledge on physics. Okay, what is atmospheric pressure? So atmospheric pressure can be represented as 1 atm or 101 kilopascal. So above the atmosphere, the pressure is 0. So at the mountain, the pressure is less than at the surface of water. So at the mountain, the pressure is 31 kilopascal. How we measure atmospheric pressure? It is using barometer aneroid or 14 barometer. Atmospheric pressure is measured using mercury. So reading of atmospheric pressure is 76 cm mercury. Because the high in a barometer is 760 millimeter. Okay, so we have pressure and head. Absolute pressure. What is absolute pressure? Absolute pressure is actually pressure in fluid. Pressure of fluid plus pressure of atmosphere. Okay, so absolute pressure is pressure in fluid is gauge pressure plus pressure atmosphere. Okay, gauge pressure is actually pressure in fluid, or we can calculate gauge pressure is absolute pressure minus atmospheric pressure. Okay, vacuum pressure is pressure below atmospheric pressure. Okay, so stated here, absolute pressure is gauge pressure plus atmosphere pressure. So this one, gauge plus atmosphere, we get absolute pressure. And the typical value for atmospheric pressure is 101 kilopascal. Okay, pressure atmosphere 0 when measuring gauge pressure at datum. Okay, when at datum, the gauge pressure is 0. Okay, let's see this. We have open container. So pressure above the surface is atmospheric pressure. When go down to the sea levels, P below is pressure atmosphere plus gauge pressure. Gauge pressure is fluid pressure. So density here, we need to use the density of fluid. If it's water, we use 1000. Pressure in liquid at rest increase linearly with distance from the free surface. So depends on the H, because we substitute the H in a gauge pressure. In liquid, the elevation is usually in terms of depth H. Why this mentioned? Because previously, still remember, in the pipe, the elevation is represented by Z. Okay, next we have pressure head. Pressure head is calculated as pressure divided by density times gravity. From this equation, we can get the units of meter. So the pressure head is in the units of meter. And one more thing you need to remember is pressure head must be the vertical height. Means that if the column is inclined, the head pressure can still calculated in vertical high. Head. Okay, so here from this pipe, we can see the pressure head here is 7.112 meter. Okay, and then let's go through the examples. What is the pressure gauge, absolute pressure, and pressure head in terms of mercury at location 2, which is 10 meter below the surface? Okay, first thing first, you need to calculate the gauge pressure using rho GH. So the inside the container is water, so we use density of water 1000, and then we calculate absolute pressure by adding the gauge pressure here and using typical value for atmosphere 101 kilopascal. So we get the absolute pressure. Okay, then we need to answer in terms of mercury head. So this is the formula to find the head. Pressure is already calculated. And then we need to use density of mercury because they want answer in mercury. And then the answer is 7.213 meter of mercury. Okay. Another examples. A mountain lake has an average temperature of 10 degrees Celsius and the depth is 40 meter. Kedalaman tasik ialah 40 meter. And this is the reading of atmospheric pressure in millimeter mercury. And we need to find the absolute pressure at the bottom of the lake. Okay, this is the lake. The depth is 40 meter and atmospheric reading in mercury. Okay, first thing first, we need to change the units to kilopascal because we need to calculate absolute pressure, need the same units of pressure. And we use formula rho GH. Density using is mercury because this is mercury. And then we get the atmospheric pressure in kilopascals is 79.783. Absolute pressure using this formula. Before we get the absolute pressure, we need to find pressure in fluid. Pressure here in fluid. So the formula is rho GH. But we are using the density 1000 because we assume density of water lake is 1000. And get the gauge pressure also in kilopascals. And then only we can calculate the absolute pressure using the formula. This is gauge pressure plus atmospheric pressure. The absolute pressure is 472.183 kilopascal. Okay, another example related to hydrostatic fluid pressure. Let's go through. The gauge pressure and absolute pressure we need to find at a point 3 meter below the free surface of the liquid. Given that the density of that fluid is 1.53 times 10 to the power of 3 and the atmospheric pressure is 750 millimeter of mercury. Given that Sg, specific gravity of mercury, and also density of water. Okay, the questions can be drawn like this. We have 3 meter below the water surface. So the H is 3 meter. Okay, so we need to find the gauge pressure and also absolute pressure. Okay, so Z here is actually H. and density is given. Okay, this is the atmospheric pressure. We need to convert millimeter to meter. We get 0.75, and then we need to change the atmospheric pressure in terms of mercury to kilopascal. We are using formula rho GH. The H is 0.75. The density is using density of mercury. Here, how we calculate density is specific gravity times 1000. We get the density. And then the atmospheric pressure is 100,062 Newton per meter square. It also can be written as pascals, same units. 1 pascals is 1 Newton per meter square. After we get the atmospheric pressure, we need to measure the fluid pressure or gauge pressure using the formula of same rho GH. The density used is density given. This is the given density here. And then the H is 3. Z. We get the gauge pressure is 45028 Newton per meter square. Then only we can calculate the absolute pressure using the formula of gauge pressure plus atmospheric pressure. So this is the answer for these examples.